Welcome back to my channel. Today's video we are going to be talking about parametric functions. So now, what are parametric equations or parametric functions? Parametric functions are like when two variables are connected with each other. For example, we have the y. We have y. Y is equal to something like 1 plus 3t. So, and then did I give us another equation like x? X is equals to 2 plus t squared, which are two equations. Now, what these both two equations have in common is that they both have t as their function. They are both a function of t. X is a function of t and y is a function of t. So now in parametric equations, if we are told to find for dy dx, we are told to derive things in parametric equation. There is a way that we go about it. We differentiate y with respect to t, differentiate x with respect to t, and then we try to cancel the derivative of t out somehow. For example, the y dt, we have this, we get the y dt here. Then in here we get the x dt. So now we look at what can we do in order to make this dy dt and the x dt become dy dx, because it's dy dx that we are looking for. We want to merge these two equations together in order to get the derivative. What do we do here? We have to get this is dy dt, abi dx dt. So we have to get the inverse of this other one when we multiply it by this in order to get dy dx. So dy dx here now will be equals to dy dt times dt dx, and dt dx is like the inverse of the x dt, and it can also be dy dt multiplied by 1 over the x dt. That is the same as finding the inverse of, so this 1 over the x dt will also eventually lead up as the dt dx. So let me just simply write it as dt dx. If we were to use normal calculation, we know the t here will cancel the t, and then we eventually have the y dx, which is going to be our answer. That is how this formula is derived. dy dt is equals to dt over dx. Now this t here is not always t. At some particular point they might put a and so on and so on. They can put a, they can put b, or any other variable. Just know that it's the y over the variable multiplied by the inverse of the x over the variable. So now let me solve this question. So first of all, here we are going to find for dy dt. dy dt. dy dt is equals to, this is 0 and this is 3. dy dt is equals to 3. While the x dt is equals to, this is 0 plus 2t. So differentiating this and differentiating this. Now the x dt, we have gotten our dx dt. We have to look for dt dx, which is what we are going to use to multiply dy dt in order to get dy dx. dt dx is equals to 1 over whatever you get as dx dt, which is 1 over 2t. So now we have gotten our values. Then we move directly. We have dy dt. We have dy dx is equals to dy dt times dt dx. dy dt is equals to 3, dt dx is equals to 1 over 2t. So our final answer here will be equals to 3 over 2t, which will be our final answer. So 3 over 2t is equals to dy dx. So now we have successfully solved a parametric equation. equation. This can work for any other type of equation, trigonometry. There are particular cases whereby even differentiating y you have to use chain rule or product rule. You can take my former videos to know how to differentiate things like that. Let me take another example, which is like a trigonometry. So let's say we are given y is equals to sine 2x, and we are given x sine 2t. Yes, and x is equals to cos t. Let us leave it as simple as this. So the same way we did it is the way we are going to keep doing it. We find for dy dt. Dy dt, differentiating sine 2t is going to give us 2 cos 2t, which is chain rule. Using chain rule, this is what you are going to get using chain rule. Then the x dt is equals to, the variation of cos t is equals to minus sine t, minus sine t. So when we got our dx dt, we are going to find for dt dx, dt dx. dt dx is equals to 1 over minus sine t, which is equals to minus 1 over sine t. So now that we have gotten all our values, we use our formula, which is dy dx is equals to dy dt times dt dx. dy dt is equals to 2 cos 2t multiplied by dt dx is equals to minus 1 over sine t. So when we multiply this, we will get our final answer as minus 2 cos 2t divided by sine t. This will be our dy dx. So this will be our final answer.